So here's our other factor me first question. And what we're going to do is notice that there's a double and a single and a single and a double. And you have to remember that you can only reduce doubles with doubles and singles with singles. A lot of times people do it wrong and then that messes up the whole process. So make sure that you know that. Our goal is always to factor first and then look for exclusions while it's factored because it's easier to do. In this case, I'm going to factor the top. This one is a GCF. Notice they both have a 25. So I'm going to take a 25 out. And when I divide everything through by 25, I get m plus 1. On the bottom, I can't factor that at all. That's just 5. On the top, it's just 4. And on the bottom, it has a GCF as well. The GCF is 30. So I should have a 30 and an m plus 1. Now, here's the good thing. We're going to pause here for a second because what we need to do is look for exclusions. Our exclusions are anywhere where the denominator has a variable. The denominator over here doesn't have a variable, but the denominator here does. And you could just take the factored part because the 30 really doesn't have anything to do with it. So if you take this part and you do m plus 1 equals 0, you can find your exclusion. So that means that m can't be negative 1. I know it says that m equals negative 1, but it's called an exclusion because we cannot have negative 1 here. And you can double check to make sure that this makes sense because 30 times negative 1 is negative 30. And negative 30 plus 30 is 0, and that makes this undefined and the whole thing garbage. So this is called an exclusion because we have to say that m can't be negative 1 when we're working with it. Now that we found our exclusions, we're able to go ahead and reduce properly. Any single with any single and any double with any double. The good news is that we have doubles that match. We have identical m plus 1s that we can reduce and become 1. Now, take a look at the rest. I've got a 5, which is a single, and a 25. When it comes out, it's a single. So I can reduce the 5 on the bottom with the 25 on top, and 25 divided by 5 is 5. So that works. I have a 4 on top and a 30 on the bottom. So I can divide each of those by a common factor of 2. So I can divide 4 by 2 and get 2, and 30 divided by 2 and get 15. And then I still have a common factor between the 5 and the 15. So 5 divided by 5 is 1, and 15 divided by 5 is 3. So I have reduced this whole entire thing to the fact that I've got 1 times 1 times 2. And that's going to give me 2 on top. And I have 1 times 3 times 1 on the bottom. That's going to give me 3. So my final answer for this question is 2/3 with the exclusion that m cannot be negative 1.